Okay, so the last general topic that we're going to cover in this class has to do with matrices, which are the plural form of a matrix. And I promise this is something that you can do, even though a matrix might seem kind of intimidating. Cramer's rule is what we're going to look at today, and Cramer's rule just uses the numbers in a matrix to kind of tell you what the solution to the system is. So Cramer's rule is basically a third way to solve two variable systems. It can also be used for three variable systems, but just because we don't have a whole lot of time left in this semester, I'm just going to tell you that we're probably not going to cover that. But just know that there is a way to get it to solve three variable systems too. But we're just going to stop short at Cramer's rule. So what were our other two ways for solving systems? Addition / elimination, right? And what was the other one? Substitution, okay. So before we talk about what Cramer's rule is, we probably should define what a matrix is. A matrix is simply a collection of numbers in rows and columns. So what Microsoft Office program uses essentially a matrix? Because it gives you numbers, or you can put numbers in rows and columns. What program is that? Excel. Okay, so Excel is just a glorified matrix, basically. So here is an example of what a matrix will look like. We usually use brackets to determine that it's a matrix, and you might see numbers in rows and columns inside that matrix. So this is what we call a 2 by 2 matrix, because it's 2 rows by 2 columns. It is always rows by columns. You always list the number of rows first. So you can have matrices of any size. And just know that what a matrix is for us to do calculations on the numbers without having to have the letters, the variables like X, Y, and Z. So this would be a 3 by 3 matrix. Both of these are what we call square matrices because they're perfectly the same number of rows and columns. Just know that you don't have to have the same number of rows and columns. It's just that traditionally we look at things that are kind of even on all sides. But what we're going to talk about today, really, and next week also, in reference to matrices, is what an augmented matrix is. An augmented matrix is a matrix basically with an extra column. And a bar that represents an equal sign. And the reason we are looking at it is because this is used to represent a system of equations. So this is what an augmented matrix, this is an example of one. It'll have numbers like before, but then it's going to have a bar representing an equal sign, and then it's going to have an extra column of numbers after. And so these numbers have meaning. When you see an augmented matrix, it stands for a system of equations. So these are your X coefficients, these are your Y coefficients, and this bar means equal. Okay, so this first row could be read as 2x plus 3y equals 5. And this second row could be read as 4x minus y equals 3. So let's look at a 3 variable one. So 3 variable one just has more numbers, has more rows and columns. but the bar with the extra column at the end indicates that it's an augmented matrix. So instead of just X and Y, what's the third column going to be? It's going to be Z, right? So this will be your X numbers, your Y numbers, and your Z numbers, and again, this is still an equal sign. So we've got 3 rows to kind of read off, right? The first one would be X plus 2Y plus 3Z equals 5. The second one would just be 2X, and then we'll skip Y, plus Z equals 5. And then this would be negative X plus 2Y plus 4Z equals 7. So it's pretty easy, I think, to change things from, equation form to a matrix and vice versa, okay? But why do we want to do that? Well, the reason we want to do that is because we're going to be able to do kind of some quick matrix math that's going to be able to manipulate our numbers and give us our solutions. But we're still looking for an X comma Y when it's a 2 variable, and an X comma Y comma Z when it's a 3 variable. So a determinant of a matrix, if you have a matrix that looks like this, okay, so let's say that you have some A's and some B's in a matrix. So all the sub numbers mean is that there's 2 different A's and there's 2 different B's. So if you're given the following matrix, then the determinant is a special kind of mixture of the numbers where you kind of cross multiply. So first of all, when you want the determinant, you're going to use these bars. Okay, so these bars right here mean determinant. So the bars mean find the determinant. And what the determinant is it's what you get when you cross multiply down and then you subtract the cross multiplying up. So essentially it is this corner times this corner. So it's A1 times B2 minus this corner times this corner, A2 times B1. So I wouldn't suggest memorizing the letters. I would more suggest memorizing how it looks, right? Cross multiply down, subtract by cross multiplying up. And this determinant is going to help us figure out what X and Y are, but for now, let's figure out just how we would find it. So if I asked you to find the following. Now what do you notice? This is a column and rows with numbers in them, right? But instead of putting a bracket around those numbers, what did I put around it? The bars instead, right? What did the bars mean? Determinant, okay? So you are supposed to cross multiply this way. So 5 times negative 1. And then you're supposed to subtract whatever you get when you cross multiply up. So minus 3 times 4. So we end up getting negative 5 minus 12 or negative 17. Okay, so for now, just know that the determinant is going to help us figure out some values later. For now, we're just practicing learning how to find it. So let's do one more. So let's say that I asked you to find this determinant. And again, you're going to know that it means to do determinant based on the fact that there's a bar instead of brackets. So again, first I'm going to multiply down this way. Okay, so I'm going to do 3 times 0 minus whatever I get when I multiply up this way. So minus 2 times negative 1. So I end up getting 0 plus 2 or 2. Kind of like before, probably the most common errors here are sign errors, especially on like example number 2 where we had a minus and negative. You just got to remember to make that a positive. Okay. Okay, so keeping that in mind, let me tell you what Cramer's rule says. So Cramer's rule for two variable systems tells you how to find x and y using a series of determinants. So let's say that this is your system of equations. I know this has a lot of letters. Just know that A, B, and C are just going to be numbers. So it's just a number x plus a number y equals a number. Okay, and then a second equation where it's the same format, but notice all the numbers are A2, B2, C2. So if you're given this, then the following determinants can be found. So what we're going to do is we're going to find a series of three determinants. So capital D is going to be whatever you get when you combine the first column of numbers and the second column of numbers. Your second determinant we're going to find is going to be whatever you get when you combine the last column of numbers with the second column of numbers. And then finally, the third determinant we're going to find is the first column of numbers and the third column of numbers. And then the solution for the system is a combination of those answers you get there. So the x solution will be whatever you got for the d sub x over the d number. And y will be the d sub y over the d number. Okay, so this is really the biggest point of Cramer's rule. Once you find these three numbers, because these are just going to be numbers, then you put this one over this one for your x. You put this one over this one for your y. So I kind of think of Cramer's rule as kind of a trick method, honestly, for solving systems. But it is actually really helpful the more variables you use, but we're going to stick with pretty simple two-variable stuff. And the good news about this is if you're uncomfortable with Cramer's rule, you still have other methods that you could kind of check your work with, but just know that you're also going to have to know how to do Cramer's rule. And as long as you can do the determinant where we cross-multiplied and subtracted, I promise you can do these. It's just a little bit of different work. So these are your A numbers, these are your B numbers, and these are your C numbers. Okay, it literally goes in alphabetical order. So we've got three determinants to find. We have one for D, we have one for dx, and we have one for dy. And they follow a very specific pattern, okay? So the pattern for D is A's followed by B's. So let's just write those numbers in. My A numbers are 12 and 2. My B numbers are 3 and negative 3. Okay? For the X, notice the pattern here is C's followed by B's. So it's going to be the 15 and 13 for the C column, and then 3 and negative 3 for the B column. And then finally, what's the pattern for D sub Y? It's still on screen. A's followed by what? C's. So all we're going to do is cross multiply and subtract, right? So this is going to be 12 times negative 3 minus 2 times 3. So let's figure out what that is. So that would be negative 36 minus 6, which is negative 42. This one is going to be 15 times negative 3, right? So cross multiply this way, and then minus this one, right? So minus 13 times 3. So negative 45 minus 39, maybe we'll use a calculator, but just watch your signs. So that'll be negative 84. And then last but not least, and then I'll be ready to find my answers, 12 times 13 minus 2 times 15. So 12 times 13 is 156, minus 30 is 126. So I'm going to circle these answers, but these aren't my final answers, right? I really need to find a point, right? I need to know what x and y are, but I'm right there at finding it. So here's the point of that. Now x is just going to be whatever we got for the d sub x over the d. Okay, so what did we get for d sub x? Negative 84, right? And for d, we got negative 42. Well, this simplifies into something pleasant. Negative 84 divided by negative 42 is just 2. How do we find the y? It's kind of obvious because of how it's labeled, but how do we find the y? You take d sub y over the same denominator. So this bottom's still going to be negative 42, and the top's going to be 126. And so you're going to get negative 3. So your final solution, just like we got with our other methods, your final solution is 2 comma negative 3. And just like before, we can check these. Okay, how do you check them? Plug them back in, yes. Okay. So one benefit of Cramer's rule, just before we look at another example, one benefit is, do you remember how our other methods, we always got one answer and then we plugged it back in to find the other one? So unfortunately, if you mess up the first answer, you also have messed up the second answer. This method is independent. So basically, you could get technically one of them right and one of them wrong. Okay, so they don't really depend on each other because they use a different formula to find x and y. We don't plug one into the equation to find the other. All right, so let's practice one more, and then we're going to talk about maybe our special cases. So when you're doing your homework online, if you don't love Cramer's rule, resist the urge to use one of our older rules or our older methods, because again, on the test, I'm going to have some problems where you at least have to know how to do one of all the methods. So try to use the method that it specifies on MyMathLab rather than using the other method that you prefer. So these are my A's, these are my B's, these are my C's. One other thing that I want to make sure we're clear on is I'm not going to ask you to memorize the orders of the numbers. Does that make sense? So like I would give you this on test 3. Okay. Now you're still going to have to know what the A's, B's, and C's stand for, and you're still going to have to know how to cross multiply and subtract, but I'm not going to make you memorize the order of the letters because that could get kind of tricky. Okay. You'll have to know that. But I mean, I think that's obvious, right? The X one is the X, right? And the Y one is the Y. So like, if you've done a couple of these, I don't feel like you really would need that formula. So, so again, we're going to come up with 3 determinants. So the D determinant, just plain old D, is A's followed by B's. The D sub X determinant is C's followed by B's. And the D sub Y is A's followed by C's, I mean. So then we just need to cross multiply and subtract. So y'all tell me, what would that look like on D? What would you start with? 3 times what? 3 times 2. And then minus 2 times negative 4. So notice I get a double negative there. So it's going to be 6 plus 8, or 14. Okay, D sub X is going to be 4 times 2, diagonally multiply and then subtract, minus 12 times negative 4. So again, we have a double negative, so it's going to be 8 plus 48, or 56. And then lastly, 3 times 12 minus 2 times 4. So 36 minus 8 is going to be 28. So these are my determinants, but they're not my final answers, right? The final answers are found by doing this over this for X, this over this for y. Okay, so x is going to be 56 over 14, or 4. And y is going to be 28 over 14, or 2. So in the end, the solution is just going to be 4, 2. So just real quickly, we can check this, right? 4 and a 2 would give us 12 minus 8, which is 4, so that's good. A 4 and a 2 here would give us 8 plus 4, which is 12, so that works too. Okay, so you can either check it mentally or check it on your calculator, but I do want you to check it. Okay, so let's talk about the special cases that you can get. Okay, the special cases are maybe there's no solution at all, or maybe there's an infinite number of solutions. And so you're going to need to know how to tell when you get that on this method. So if d equals 0, d being the first determinant we find, and d sub x and d sub y are non-zero numbers, then the system has no solution. And remember, we came up with a different word for that. That also means inconsistent. Okay, so if d is 0 and then we get non-zero values for the other two, then the system has no solution or is inconsistent. Okay, so an example of this, I'm not going to solve it all the way. We'll do an example of one in just a minute. But it would be like if you went along and you got like 3 over 0. Like you did all 3 of your determinants, but when you tried to stack them on top of each other in the fraction form, you got 3 over 0. 3 over 0 is undefined, right? We can't have 0 on the bottom. Okay, so when you get that, we're going to say inconsistent. And this section, I believe, in my lab does use the terms inconsistent and dependent for the other one, not no solution. But know that those are the same thing. Inconsistent and no solution are the same thing. Okay, so the second special case is, again, if d is 0, but also d sub x and d sub y will be 0. So this time they're not non-zero, they're actually 0 as well. Then the system has infinitely many solutions. Remember, the term for that is dependent. And a solution would be any point on the line. So kind of underlining the significant things there. So that would be if you were going along with your method and you got 0 over 0. So instead of like a number over 0, you get both things being 0. So this means dependent. Slash any point on the original line. So last class we looked at some pictures, and remember, most of the time you're going to cross at one point, meaning you have one solution. Sometimes you're never going to cross, meaning you have no solution. And then sometimes the two lines are right on top of each other, meaning they share all the points. Okay, so that's infinitely many solutions. But honestly, you may not always know that it's going to come out that way. Okay, so you're just going to solve as you normally would. So let's say I gave you this system. Now, I also want you to notice that this really isn't looking like it's supposed to look, right? So we do need these terms in order because remember we talk about the A's, the B's, and the C's and it has to go in alphabetical order. So I need to make this equation look like the rest of them have been looking, right? So I'm going to add 3y to both sides here. So that's going to give me 3x plus 3y equals 2 for the first equation. And then I'm going to add 2x to both sides here. And that's going to make it look like 2x plus 2y equals 3. So I've got 3 determinants to find. So the regular, the first one is just the A's followed by the B's. The second one is the C's followed by the B's. And the third one is the A's followed by the C's. But what do you notice is going to happen all the time on these? If you cross multiply and subtract here, for instance, you're going to get 3 times 2 minus 2 times 3, which is what? 0. Okay. Then you're going to do the same thing here, right? So you're going to get 2 times 2 minus 3 times 3. So you don't get 0 this time, right? You get negative 5. And then here you're going to get 3 times 3 minus 2 times 2, or 5. So the problem comes when you try to come up with your solutions. So let's talk about it. If you tried to, you're going to say what for x? You're going to say, oh, it's negative 5 over 0. Okay? But the problem is that this is undefined. And frankly, remember the gist is this 0 or not? Notice this is a non-zero. So it means that the system is what? The system is inconsistent, and that's just a new way of saying has no solution. Notice I didn't even bother moving on to my y term because it had the same result, right? I was going to get 5 over 0, so there was no reason to put it there. So on MyLab, there will literally be a multiple choice option that says no solution / inconsistent. All right, so let's do one that might turn out the other way. So 2x plus, let's change that to a 3. 3x plus 4y equals 16, and 6x plus 8y equals 32. So we're just going to proceed with our 3 determinants, just like we always do. And then if we get something unusual, then we'll think about what that means. So the first one is A's followed by B's. Second one is C's followed by B's. And then the final one is A's followed by C's. So let's work it out. 3 times 8 minus 6 times 4. So 24 minus 24 is 0. By the way, right now you know it's one of the two unusual situations, okay? When 0 is the D term, it depends on whether these are zeros or non-zeros, honestly, okay? So this one's going to be 16 times 8 minus 32 times 4. Both of those are 108, just so you know, so this comes out to be 0 as well. So I'm going to go ahead and do this one, but honestly, right now you already kind of should know what the conclusion is, because we already have an answer there. But let's go ahead and finish it out. 96 minus 96 is 0. So when you get to getting your x value, you're going to say 0 over 0. Notice this time this is a 0 too, just like the bottom. So what does that mean instead of what we got in example 5? It means the system is dependent. Okay. In other words, it has infinitely many solutions. But we're going to say more than that. It's actually any point on the original equation, and you can pick really either one. It's any point on 3x plus 4y equals 16 is a solution. So it's not just infinitely many solutions, because we can actually describe what those solutions would be in this case. So no solution is quicker to talk about because there's nothing to discuss. There's just no solution. Infinitely many solutions, we want to describe what those solutions are. Okay, so I want you to try one on your own, and I want you to use the patterns we've been talking about and see if you can get the answer for the next one. So I'm going to give you like 2 minutes, and I want you to see if you can get the answer that you should be getting here. And furthermore, you should be able to know if you're right or not by doing what? Checking it if it's an answer, right? So I want you to use the ABC pattern thing. So how many determinants do you need to find again? 3. Okay. So see what you can do with that. So Jacob, you're going to do it too, right? Not just stay on your phone the whole time? That'd be good. All right, so let's see, most of you look like you're finished. So this one is A's followed by B's, I mean. This one is C's followed by B's. This one is A's followed by C's. So on test 3, like this is what the formula should be able to get you, and then you still have to know how to proceed from here, right? You still have to know how to cross multiply and subtract. So we got 4 times -2 minus 2 times 3. So watch your signs. It's going to be -8 minus 6, which is what? Negative what? So did I write down the numbers wrong?
Yeah, I was gonna say, yeah, you switched to 4 and 2.
Oh, yeah, I shouldn't do that, right? I did switch to 4 and 2, which does matter. Okay, so let's not do that. I don't think I did that anywhere else, did I? Okay, so let's get rid of this. So, I mean, kind of like I said, the errors that you probably will make on these will be goofy ones like I just tried to do. So you can't switch the order of the letters, you have to go in order. So you get -4 take away 12, which now that looks right? It's -16. On this one, you're going to do 6 times -2 minus -4 times 3. So really careful about your signs. It's actually going to be a -12 plus a 12, right? What's -12 plus 12? 0. By the way, 0 is okay here. It's only 0 here that gives you an indication that something's weird and that you have no solution or infinitely many solutions. So you shouldn't stop at that point. You should keep going. So 2 times -4 minus 4 times 6 is going to be -8 take away 24, or -32. So for x, you're just going to get 0 over -16, which is not no solution, right? 0 over something is actually what number? 0. Okay, so if you thought that was a no solution, that's actually why I gave you this one. I wanted us to see that 0 can be a legitimate answer for one of them. What we can't have is 0 on the bottom. 0 on the top just means the number 0. And then here we're going to get -32 over -16, which nicely reduces to what? 2. So your solution, which you of course could check by plugging it back in, would be 0, 2. Okay. So where is the 0 not need to be? I mean, it can be. The 0 doesn't need to be here, right? Because that's what's going to go on the denominator. Okay.